only have a certain amount of quantity in this world, and that amount remains the same, well, the pressure on water is increasing. We really have to be clear that we use the water we have in the most efficient manner. If you compare, for example, WASH, they have one indicator which says how many people do have access to drinking water. Now, if you look to integrated water resource management or you look to water resources, there is simply no indicator. So what we've tried to do is to see how much water is used by agriculture, the main user of water worldwide. If we have one indicator, so we know how the water is being used in agriculture, then having that indicator, from there onwards, you can see what the reasons are. Is it irrigation? Is it many reasons we can think of? You have countries where people have no access to drinking water, and at the same time the water in agriculture is very inefficiently used. Well, that doesn't match. So you have to make a decision. Are we going for domestic use? That means you need more water for domestic use, but then also the water you use for irrigation. Do you need it? And if you need it, use it in the most optimum manner. So that's basically the whole issue about water productivity.
One important thing that was missing with any study was the monitoring of water productivity. So a lot of innovative technologies have been found, but no way to monitor if it's actually improving water productivity. So that's why this database was evolved, funded by the Dutch government, to actually monitor water productivity and see how it changes through time and also see how it changes through space. So that's how it originated, this project, and the Dutch government involved the FAO because they're specialized in agriculture and they're a union organization, so they could carry this project. It's called the FAO Water Productivity Database. It's also referred to as the WaPOR portal, and it gives spatial information about water productivity over the whole African continent and the Near East. And it shows spatial data between the times of 2009 till moving forward 2019, and it's on different spatial scales: 250 meters, 100 meters, and 30 meters in select areas. Of course, our goal is to bring it to the end user. The users itself of the database are quite varied. It's not only the farmers, it's also policymakers, because there's also data at a national scale. It's also scientists who first go to an area and have no idea what's happening in the area, so you can first use the database to get some initial information about what's going on in the area you're researching. But also the end users are farmers, and what the idea is to develop some apps that they can use on their smartphones that are very practical, such as like showing them what the timing is for irrigation. And these will all be developed within the project as well, by FAO and by EMI. And our role is more at a national scale to inform the governments how they can use this database to see the spatial variation within their own country and seeing where they can focus their projects on to improve water productivity.
First country in the world, we put water productivity, at least how you could make efficient use of water in agriculture as the main user, to put that as a target in our national program. That forces us also to think how we can broaden the whole concept. Now, even in the Netherlands, it's not even something that is perceived as a very important topic. So that's why the ministry thought, if we at least could first build on a community of practice here, then at least we get a support base in order to make it a worldwide approach. And the more people start thinking about the concept, the more guarantee or the more success we will have by measuring our water resources worldwide and see that we have sufficient water for food and for domestic use and for the ecosystem and for industries in the future.